You need your homework because we're going to turn that in for a grade. You need your notebook because we're going to take notes over this process known as the cell cycle. And actually your homework was about it as well. So we're going to try to solidify this in our minds today. Yes?
My homework is in my locker.
Ooh, go grab that real quick, okay? And then you also need your textbook. All right, so here's why you're here today. First of all, we're going to review DNA replication. Now, that shouldn't take too long. In fact, I have an illustration already on the board. It's the same as what should be in your notes. You're going to help me review that real quick. And then we're going to watch just a real quick, short little video about how magnificent your DNA is. And of course, it's getting duplicated in your body all the time. But after that video, you're going to take a quiz over DNA replication or protein synthesis. Just know they go by both names, okay? It's a short, sweet quiz worth 6 points. All right, yes, Joe?
Do you want us to write the title for our notebook?
Today's brand new title for today will be this here. We're going to call it Cell Division. In fact, what I'll do is underline it for you. So Cell Division will be our title for the day, for our new notebook entry. And you had homework on Friday to learn about this big, long process known as mitosis. Boy, mitosis is a pretty lengthy process, but it's happening in your bodies right now. In fact, it's helping you grow and thrive. So what we're going to do is learn each and every step of this process, okay? So today we're going to take quite a bit of notes, quite a few notes. But then tomorrow we're going to take all this that we learned and we're going to apply it to build models. So we're going to model what happens in mitosis using Oreo cookies. So just a reminder, you can contribute a pack of Oreo cookies. I think I saw some on the package. Awesome.
I'm Brayden.
Awesome. Thank you, Brayden. You can contribute Oreo cookies to help out. Just make sure you bring them in tomorrow. If you have them today, you can leave them over there on the little bench, and that will help our classes. So thank you. Now, in the process of mitosis, we have this bigger name for it. We're going to learn, we can call it the cell cycle or cell division, but check this out. Check this out. We have interphase, that's a phase. Then we have mitosis, that's a phase. But then under mitosis, I have 4 steps. And in the video, you notice the video called that PMAT. We're going to learn those 4 steps as well. And then finally, the last phase out of the 3 is cytokinesis. Whew. It's a lot, isn't it? So we have 1, 2, 3, 4, 5, 6, 7. 7 steps to follow in cell division. Ooh, which also means you get 7 cookies tomorrow. And then finally, you turn your homework in for a grade. Now, I want you guys to quickly help me out in doing a quick review. So, up here on the board, I have drawn a cell, much like the cell of your body. Probably more handsome than the cell I drew. But in this cell, there are parts and pieces which you know about. And in fact, right over here on this side, I have the control center of the cell. Who can tell me, what do we call the control center of the cell? Madeline? The nucleus, right? That wasn't difficult, was it? Now, inside the nucleus, we have this X. Who can tell me what this X is inside the nucleus? Jackson?
A chromosome.
That is indeed a chromosome. And then coming out of the chromosome, we have this double helix ladder, don't we? What do we call that double helix ladder? Let's see here. Yes?
DNA.
DNA. Okay. So I'll label that. Now you know that in DNA replication or protein synthesis, the nucleus makes this half copy, a half copy of DNA made in the nucleus. What do we call that half copy? Owen?
RNA.
RNA, right? Now we could also call it mRNA, which means messenger, right? And it does have a message, doesn't it? It has like half of a message. It's going to send that message or send that RNA over to this blue cell part or piece. What do we call this blue cell part or piece? the ribosome, isn't it? Now, before the RNA reaches the ribosome, what do we call this entire process? Everything that just happened inside the nucleus, what do we call that whole process on that side? Hmm?
Transcription.
Trans what?
Scription.
Are you sure? It is. Transcription, right? The C comes before the L. So we call that transcription. All right. So now the other half of protein synthesis. You may be going, why are we reviewing this? Why are we parking on this so long? Because you're taking a quiz over it in just a few minutes, okay? All right. So once the RNA arrives to the ribosome, then it sucks in and pulls in all these little particles. What are these little particles called? Sully?
Amino acids.
Amino acids, right? So they get sucked into the ribosome. The ribosome is that protein building factory. And then what gets spit out over here? Huh. Davis? New DNA, right? We'll say new. How many of you guys think you could take a quiz on that and do awesome?
Maybe. Yep.
All right. We'll do one more thing before we take the quiz, okay? I'll encourage you to review the illustration in your notes. That'll help you on the quiz. Also, let's do this. Let's watch a little short video about your DNA and how amazing it is. Just a really short video.
If simple water molecules that form ice crystals exhibit magnificent structure, consider the design ingenuity behind large, complex molecules, such as DNA. DNA contains the blueprint for all life and is by far the densest information storage mechanism known in the universe. For example, the amount of information contained in a pinhead volume of DNA would fill a stack of books 500 times higher than from here to the moon. The program code and design of such an incredible system indicates a supremely intelligent designer.
The evidence to me that just cries out that there's a God is the study of DNA. DNA is a very powerful, massive information storage system. In fact, DNA that makes up our genes actually is like books of information that's read by a language system. It's absolutely phenomenal. And scientists know today that languages, a code, only come from an intelligence, and information only comes from information. Nobody's ever seen matter by itself give rise to a code. Nobody.
Well, that makes sense, right? Mm-hmm. If you hear someone speak a language, where did the language come from? Did it just magically show up? Mm-hmm. Obviously, mankind invented language, right? So he's saying the same thing about DNA. If we look at DNA, did it just evolve a million of years? Or is there a designer and creator behind it? And DNA is a language all in itself, isn't it?
Nobody's ever seen matter by itself give rise to information. And as you look at DNA, it actually cries out, in the beginning, God created the universe.
We all begin as a single cell the size of a period at the end of a sentence. How does that cell know how to build a body with 100 trillion cells in it, thousands of different kinds, and each one of them is so complex, nanochemical machinery beyond our comprehension how it works. And encoded is the instruction manual. It's the manufacturer's manual how to build and operate every part of this incredible body made up of 100 trillion cells.
Furthermore, DNA is a three-dimensional molecule that is self-replicating. Each molecule is able to make an identical copy quickly and efficiently.
Yeah, RNA, right?
The Lord has even programmed DNA to detect and correct replication errors.
Ooh.
These sophisticated capabilities far exceed man's means.
God has created the DNA molecule in such a way that it is self-correcting. There are special proteins called enzymes that go up and down the DNA molecule looking for and making repairs on a minute-by-minute, second-by-second basis.
Wow, that's amazing, isn't it? So even after the RNA gets converted and changed back to DNA, it still has enzymes traveling around making like autocorrect. Like autocorrect on or spell check on your computer, right? Or in your texting. Pretty amazing. Does that reflect the designer creator or just random chance?
Designer.
Definitely shows evidence of a designer creator, doesn't it?
God created us with a DNA code that actually has what we call an editase or editorial type enzymes. Just as an editor reads a newspaper or a book looking for mistakes, so God has created special enzymes that go up and down our DNA molecule, repairing the mistakes in ways that are unbelievably complex.
There are many examples in creation of things that demonstrate the biblical God. One would be in our very DNA. Our DNA has information in it. And there is a whole field of scientific study called information science, which studies how information originates, how it's transmitted, and so on. And one of the laws of information science says that information never originates by itself in matter, never spontaneously comes about. Anytime we trace the copying of information back to its source, it always comes back to a mind. And since we have creative information in DNA, that tells me that DNA comes from intelligence. It's not something that could possibly come about through millions of years of mutations and natural selection. That just won't work.
Yet even the DNA molecule is simple compared to cells. All life consists of cells, and each cell functions as a miniature city. When we consider that a human body consists of trillions of cells working together as one unit, we should be in humble awe of our Creator's intimate care and perfect wisdom.
Wow. Does that give you appreciation for what God did for you? So intricately planned and organized, right? All right, so Davis is going to bring around your... So she's going to go by, pick them up, and I tell you what, the rest of us, let's get our notes ready for today's lesson. All right, so today's note title will be called Cell Division. What's the title?
Cell division.
Oh, good. So let's open up our table of contents, please. Write in today's date. New month, right?
Yeah.
Now then, open up your table of contents.
Today the second or third?
Cell division is our title. Today's date is the
Second.
second. Thank you. Yes, cell division is our title. In our textbook, we are going to be on page 96. All right, guys, so at this point, everyone should have their notebooks ready to roll. Everyone should be on textbook page 96. So, let's get started. Now, like I said, today is going to be kind of note heavy, okay? I'm sorry. But we need to get it in our notes so it's there as a resource for us. And then tomorrow, we're going to take what we write in our notes and create models of what we've learned. So Friday's homework introduced you to cell division. Today we're learning it in detail, taking great note over it. And then tomorrow we model it using Oreo cookies stuffed with Oreo cream filling. Ah, it's exciting. All right, so let's get things rolling here. On page 96, the first paragraph under cell division. You guys follow along and fill in the blanks, okay? Here we go. Cell division occurs when one
Cell.
the parent cell, divides to produce
Two.
new cells or
Daughter cell.
daughter cells. Now it can be compared to building a new factory that is an exact replica of
An old one.
an old one. Animal cell division is discussed in this section because it is fairly typical of the cell
Division.
carried on in most types of cells. So cell division, it's happening in you right now. It's what allows you to grow. So let's see all the steps included. The first step in cell division, I'm sorry, we didn't define cell division, did we? Oh, yikes.
It's to build a new factory.
All right. So cell division starts with the parent cell that's going to grow and divide into two new daughter cells. cell division, the parent cells and the daughter cells are identical. They're like twinsies, identical twinsies. They're going to be just alike. And here you see a picture of it. This is one cell that's growing and dividing and becoming two cells. That's also happening in you right now. So in cell division, if the parent cell has 46 chromosomes, how many will the daughter cell have?
23. Oh, 46.
46, it's identical,
Oh,
right?
Yeah.
So remember, in cell division, the parent cell and the daughter cells are identical. They're just alike. They're like exact copies that you've taken copy at the copying machine. All right, now, in cell division, we have 3 stages. Overall stages or phases, you might call them even. But these 3 stages are listed here on the board. Does everyone have this? Am I going too fast? All right. I'm going pretty speedy. All right, here they are. The 3 stages of the cell cycle. We have A, interphase. That's the first phase. Then B, mitosis. And it has nothing to do with your toes. Or your sisters.
Sis.
And finally, the last phase, cytokinesis. Sounds fun.
Sounds.
Now, did you know that you're already a cellular expert on one of these 3?
Oh, I know.
We already learned about one of them. In fact, you just took a quiz over one of them. Protein synthesis, or DNA replication, is, does anybody know? Do you know which one it is?
Is it interface?
It is. It's interphase.
Right.
Interphase is DNA replication or protein synthesis. What you just took a quiz on. Whoa. You were like experts on one part and you didn't even know it, right? It's kind of like being a poet and not knowing it. Making a rhyme all the time.
Rap song.
Wow. So, let's have one of you guys introduce us or just recap interface for us. It's the next paragraph there, just under interface. It's labeled for you. I'll pull out the old randomizer just to give everyone fair chance
Can
and
we leave
opportunity.
blanks for the class to fill out?
What's that?
Can we leave blanks for the class to fill out? Like. when we're
Oh,
reading
you
it?
like doing that?
Wait, what?
If you get called on, so we'll see.
LJ Handler.
All right. Sorry, that was period 2. Wrong class.
Period.
Poor L.
Period 5. We're in period 5. All right, who's it going to be?
Jackson McGahee.
All right, Jackson. Sorry, Siri messes your name up.
Before construction can begin, copies of the old factory blueprints are to be made. These copies are to be stored in the new factory's computer. The same is true for a cell. The first stage of the cell cycle, during when genes are copied, is called interphase. The genes are located on long, thin chromosomes that appear as fuzzy materials at the nucleus. And all the genes in the chromosome have been duplicated. Two identical chromosomes are called sister chromatids. Chromatids.
All right. Well, that's actually what you just learned. So, interphase happens right before mitosis, and it's what a cell spends most of its life doing. So if this were a chart of how a cell spends its life, it spends about 90% of its time doing interphase, just making copies of its DNA. Turning DNA into RNA into DNA. DNA into RNA into DNA. Just 90% of its life is done doing that.
Do you think they ever get bored?
I don't know. You should ask a cell.
Maybe that's why they're glitches in the DNA, because they get bored.
You should call it up on your cell phone.
Oh, that one was
Oh, I
actually
have
pretty
an
good.
iPhone.
That one was pretty good.
Andrew, I can't call
No, we're on
an
the
iPhone.
iPhone.
I'm a cell.
Yes.
Mitosis.
All right, so interphase happens right before the second phase, known as mitosis. It's where DNA is making copies, and it's basically DNA replication. Isn't that cool that you already knew it? So if interphase is first, the next stage is what we call mitosis. And in mitosis, there are 4 steps that occur. Not a 2-step. It's not a 2-step dance. It's a 4-step dance. It is kind of like a dance. In a dance, it's orchestrated, isn't it? There's movement at a certain time, like musical theater. When you guys put on your production, it was so incredible the other day.
The other day.
There was a lot of orchestration, wasn't there? There was a lot of planning in that, you know, when to move at the exact times. Well, that's kind of what's happening here. The different series of the play, different, what do you call them? Musical theater, what do you call the different sections of your play?
Acts 1, Act 2.
Acts, okay, thank you. Sorry.
I was thinking,
So this is like Act 1, right? Or Act A. Okay.
it's actually multiple acts.
Okay. So let's move on to Act B, the next one, okay? In the next one we have mitosis. But notice mitosis is built up of 4 different phases. Now you don't have to write this in your notes, okay? But let's get introduced to each one. What happens in prophase? What happens in metaphase? What happens in anaphase? And what happens in telophase? Well, let me tell you.
Oh my gosh. Actually, not that bad.
You planned it? I wasn't too bad.
No, it just happens. I don't even plan these things.
It's amazing.
Prophase, the membrane around the nucleus disappears and the chromosomes begin to coil up. When they coil, they no longer look like a fuzzy mass. Instead, they are visible as individual chromosomes. Each chromosome is composed of 2 identical sister chromatids that are attached at the middle. The sister chromatids often appear X-shaped by the end of prophase. Also, during prophase, a spindle of fibers forms all the way across the cell. These fibers move the chromosomes during the next 3 phases.
All right, thank you, Jack. Now, so you see here, the genetic information is starting to coil up and form into these X-shaped chromosomes. So it's not just loose anymore from interphase. It forms in these X's, right, in the chromosomes. So that happens first. And then, after the DNA coils up, we're going to see those chromosomes to begin to appear as an X. And you know that X is made up of 2 sides, right? We call each side a sister chromatid. So, you see the chromosomes pictured there, right? Now, what did it say happened to the nucleus? Did you catch that? Do you see a nucleus in that cell on the screen? Uh-oh.
No.
The nucleus dissolves and disappears for a while.
So every cell is prokaryotic in its life?
So even a eukaryotic cell will eventually lose its nucleus to do this whole series of steps. Pretty amazing, huh?
Eventually, in 3 seconds.
So that nuclear membrane disappears and vanishes away. And then these really awesome pieces begin to form. They're kind of they remind me of Spider-Man spiderwebs, you know? They're called spindles. And on here they do look like spiders, don't they?
Yes.
So the centromeres begin to shoot out spindles, which are like spider webs, and they're going to reach down and start grabbing stuff and moving it around all over the place. Isn't that pretty amazing? That's going on in you right now. So these spindles are moving things in a lot of your cells right now.
Spider-Man.
No. Oh, that's bad.
That's bad.
What's Spider-Man's theme song?
I've never seen, I've only seen one superhero movie in my life.
Which one?
The second to last one.
Infinity War?
Yeah.
I've never seen this. Be quiet, everyone, don't spoil movies.
I
I've never seen any other one but that one, and so I have no idea what's going on.
I
I'm
just
not
came
allowed
out
to watch
Avenger
PG.
movies.
I kind of knew who
Bond
some people
passed
were,
away.
like the main people
The
that
guy
I
who
know.
played James Bond, or the
Oh, Jason Bourne? No.
no.
James Bond died.
Jason Bourne.
The old one, the
That
old
name.
version.
James Bond died.
Sean Connery. Sean Connery passed away.
Oh, push.
So anyway, that made me think of it.
I don't know who. I don't even know who that is.
So does everyone have prophase written down?
Yes, sir. Wait, no.
Oh.
Spindle's form.
By the end of tomorrow, you should be a pro on prophase.
I heard somebody
Because
go.
you not only read about it, you did homework about it, you wrote notes about it, you're also going to model it on an Oreo cookie.
Cookie. I like how you said cookie. You're like, cookie.
I like cookies too.
I love
All right,
cookies.
so next we have metaphase. Now notice in metaphase I have highlighted the M because everything's happening in the middle. Let's see here. Kendall, could you read that really long, lengthy paragraph about metaphase, please? I hope you can handle it.
Is it super short?
I see it.
One sentence.
Got me. I was like looking for a long thing. I was like, I don't see it.
It's the lone little sentence at the bottom of page 96.
In metaphase, all the sister chromatids are lined up at the center of the spindle. I'm out of breath.
Okay, so at the center, we could call the center the middle, right?
Yeah.
So in the middle, so all these spindles start moving around, little spider webs start moving things around. So all the chromosomes line up in the middle. Now you can simplify this. So the chromosomes line up in the middle. You can simplify this in your notes. Sorry.
That's longer than the text.
I got worried. It's longer than the text.
Those are longer than
Why?
Well, you can simplify it.
I'm
That's
supposed
that's
to
longer
do
than
that.
Aren't you glad I said you can simplify it?
Aren't you glad?
Aren't you glad?
It just works when an actual dad says it.
He is an actual dad. He's not
Exactly.
your
That's
dad.
why I said that.
Oh, okay.
Dude, that only took up 1.5 lines.
I know.
I shortened it out. I said these cis chromatids are lined up in the middle of cell by spindles.
So chromosomes line up in the middle. Short, sweet, and simple. All right, so that brings us to anaphase. And in anaphase, things are going to start moving away from each other. They're going to move apart. And notice anaphase starts with what letter?
P.
An A, to help you remember, right? So in anaphase, what in the world's going on in anaphase? Let's have one person to read and share the paragraph on anaphase, please. Oh, Max, and I see you back there. You get that paragraph, please. Alright, so opposite ends of the cell. And we can see here, the spider web spindles come out. They rip apart the chromosomes. Notice that?
They look birds.
So one set of sister chromatids are on this side. The other set is on this side. So the spindles rip them apart and then begin pulling them in opposite directions, pulling them away from each other. So, each pair of sister chromatids is separated from the chromosomes and moved to opposite ends. So they're moving apart.
And there would be 23 chromatids, right? Not just like the 5 that are shown there.
Right, so if it started with 46,
Well, 46,
then
yeah.
23 on this side, 22 on this side. But in humans, when this happens, there would be 46 on this side, 46 on this side, when it happens in us.
Oh.
This is simplified, because it would be hard to put a lot of chromosomes in there. And the models we create tomorrow will also be simplified, because I don't think we can fit 46 sprinkles on it. I mean,
I can
We
eat.
probably could.
I could eat 46
we could,
sprinkles.
keeping them separated, like separate and where they need to be. So isn't that cool? We're going to actually demonstrate what each step models and shows to us tomorrow on Oreo cookies. And you like that part?
Wait, are you bringing sprinkles from from home, or are you getting it from like the kitchen?
I will bring sprinkles.
Okay, because Miss Lainey hid the sprinkles from us because
We're trying to sabotage my cupcakes, yeah.
Oh.
Well,
no,
not my cupcakes,
I wanted
no, my,
sprinkles on my stuff, and she was like, "You guys keep making a mess with the sprinkles." And I'm like,
Uh-oh, no
So
sprinkles
she
for
hid them
Kendall.
from us.
She probably ate them all.
Yeah, she probably did.
All right, and so the next step starts with the letter T, doesn't it?
Yep.
So we had anaphase with an A, now we have telophase with a T. So who would like to tell us? Who would like to tell us what happens in telophase? Drew, would you like to do that?
During telophase, the daughter chromosomes reach the end of the spindle and begin to uncoil. As they uncoil, the spindle disappears and a new nuclear membrane form around each group of chromosomes, and this results in two new nuclei, each containing a complete copy of the cell's chromosomes.
All right, thank you. So you can see here, now then, these spindles start going away. They're not needed anymore because things aren't getting moved around so much. So we have
The spiders are
the
fading.
DNA here and here, and notice a new nucleus is forming around it, right? And that's going to split and divide and become two cells.
That kind of looks like a peanut. The outside.
I can see that. It kind of does look like a fat peanut.
That's what it is.
So we have the daughter chromosomes reach ends, so they move to separate ends, right? Then they begin uncoiling again, like they were originally. And a new nucleus forms around both sets. And two nuclei form. And eventually we're going to have two cells as a result, aren't we?
I think a cell gets the most phone calls during a telophase.
Ha ha ha.
Oh,
Ha ha.
I like that.
Where are the guys in all this? All the girls are working hard in this. Like,
Yeah, honestly.
ugh.
We're out doing fun stuff.
Ugh.
Okay, please stop. All right, so you can see why I highlighted T, right? Two nuclei, two cells are beginning to form telophase. All right. And so that brings us to the very last step, the last phase of this whole lengthy process that cells are living to do. It's a living. It's what they do.
They die. Sorry.
Oh
I don't know
no,
why.
they duplicate themselves and form new cells.
And then they die.
So they don't die.
Never?
All right, so what's the last part or piece? Everybody.
Cytokinesis.
Cytokinesis. I heard you. Thank you. You answered to everybody today, didn't you? All right, would you please read the section about cytokinesis?
Both paragraphs?
Just the first
Okay.
paragraph's good.
Cytokinesis is the final stage of the cell cycle. This process provides each daughter cell with some cytoplasm and organelles. The parent cell pinches in between the two new nuclei until the cytoplasm divides and two new cells are formed. It is unimportant if one new cell gets slightly more cytoplasm or a few more organelles than the other. Since both new daughter cells have a complete set of blueprints, genes, they can make any cellular parts that they need.
All right. So that's the whole purpose of the whole process, right? So one cell can grow and divide and become two cells. And you can see that's kind of what it looks like under a microscope. So we have the parent cell. Now we have two daughter cells produced as a result, right? If the parent cell had 16 chromosomes, how many would the daughter cells have?
16.
16 as well, right? They're identical. They're just alike. Now each cell gets its brand new nucleus, its own cytoplasm, and its own organelle, so it can start the whole process all over again. And so that is cellular success right there. That's living the cell life. Doing what cells live to do. Grow and divide. Grow and divide. Yeah, so
How long does cell division last when you die?
so like a person passes away.
Yeah, and then it's cell division.
Yeah, it's gonna be an
Like,
some will continue
like how long would it take for all of it to be on?
right with that. Because everything's shut down. All the energy supply to your cell is shut down. But a little bit will happen. This is kind of gross, but after you die, your hair will continue to grow long. Your fingernails will continue to grow.
And also I think if your fingernails don't grow, it's just that your skin is crawling away.
Yeah, that's true.
Yeah, Googling.
Google me.
That was a little disgusting.
Sorry, it was.
Okay, a lot.
I'm not disgusting. All right, so the entire process, if I were to put it up here on the board, it'd look like this. We have interphase first, right? That's where the cell spends most of its life. Then it goes through prophase, metaphase, anaphase, telophase. Those are the four specific stages of mitosis, okay? PMAT, like in your video. And then finally, cellular success, we have the cells grow and divide. Cytokinesis is where they become two new daughter cells. Yes?
So for our test, will we need to know the entire cell cycle? Like
Yes.
what?
For your test, you'll need to know the entire cycle. You'll need to know interphase, the 4 steps of mitosis, and cytokinesis, okay?
Will we need to know what they do and what happens?
Yes. You will need to know what happens in each step. And like I said, tomorrow, we're hitting this several ways. From your homework from Friday, your notes today, you're going to turn your homework in for Friday. Tomorrow we're going to model it.
Beautiful.
With Oreo cookies, so we can do that tomorrow. And yeah, we're spending some time on this because it's a pretty lengthy process.